Greetings everyone. Welcome back to VLSI for all. Today we have Dr. SWARIT who has done his PhD in chemical engineering, and through this podcast we are going to know more about this career field. So over to you, SWARIT. How are you doing?
I'm doing pretty good. It's cold in here.
Mm-hmm.
I'm in State College, Pennsylvania right now,
Okay,
and it has been snowing for last 1 week. So yeah, enjoying it.
okay, that's something cool.
Yeah.
Okay, so let's start with your career journey, starting from your undergrad. So where did you completed your undergrad from, and how would you like to rate the college?
All right. So I've done my undergraduate from HBTI Kanpur. So that is a Hardcore Butler Technological Institute, which has now become a university. So it's a Hardcore Butler Technological University, and it used to be one of the finest state government college of Uttar Pradesh. Now it's a university, so obviously it's taking candidates from all across India. But yeah, I've done my undergrad from there, and I've done my undergrad in not in chemical engineering. Basically, I've done my undergrad in chemical technology branch.
Hmm.
So there's like a pool of branches in HPTI because it's one of the oldest engineering colleges of India. So pre-independence, basically they used to have technologists. So they used to have paint technologists, oil technologists, food technologists, as well as leather technologists. And these pool of branches are called as chemical technology branch. So one of the branch that I did my undergrad from, it's called as leather technology. So it's chemical technology slash leather technology. Now about ranking my college, I would like to rank it pretty high in terms of alumni relationships, in terms of the kind of students that you hang around with in those 4 years. They are all brilliant, come from diverse background of UP. I would say not as diverse as getting people from all across India, but yeah, a lot of brainy people you hang around with in those 4 years. Great alumni network, great placements. It used to have a baggage of being a traditional government college, that you get limited resources, uh, some people with limited interest in teaching you, that being your professors. But over and all, fantastic experience, and I would recommend anybody to do their undergrad from HPTI.
Yeah, yeah, true. Actually, I recently had an interview with another alumni, and also
uh,
he was from HBTI, and he was also
oh,
happy with his education from there.
yeah, okay. Cool, good to know. Yeah.
Yeah. And I want to ask, why chemical engineering? Like, what interested you to choose this? Very few of people actually go for chemical engineering, in my
Uh-huh.
opinion.
So yeah, so to be like completely honest with you, it was not by choice. So it was like, okay, what rank are you getting? Okay, and what college are you getting from that rank? And they used to be like the time when I started my undergrad, there was this there was this herd going behind engineering. So everybody wanted to do engineering. So I never thought,
Hmm.
and I was like, okay, I'm good in studies, so I'll do engineering. So and not even engineering, you don't even think about engineering. Like everybody's like, okay, do IIT. So IIT was a bigger tag than being an engineer.
Hmm.
And then I gave my IIT examination. There was some unfortunate incident, and I somehow fell short of 3 marks, I guess, for being selected. And I did good in AI Triple E that year. So like I did as good as I was getting NIT Calicut and some other places
Hmm.
in proper engineering, physics, and other branches. But unfortunately, I did some stupidity there as well. In during the counseling process, it was supposed to be online for the first time, and it was a chaos. So, anyways, I had to choose a college based on UP state entrance examination, and I chose HBTI. I didn't give preference to branch, but I gave preference to college, and I regretted that decision. So I was good in physics, and I wanted to be close to physics,
Mm-hmm.
and especially modern physics, where you think about molecules, you think about particles, you think about things at very tiny scale. So ever since that, it's very hard to change your field in India, to be
Right,
honest.
right.
Once you have opted something, and I have literally tried my best to change my field even after bachelor's. I did try that. And there's an interesting story about IIT. I'll probably tell you later. So I tried hard to change my field, but I could only do it gradually. So I chose leather technology in bachelor's, which I got. Masters, I got chemical engineering by luck. Not by luck, like it was very kind of them to offer me chemical engineering, although I was from chemical technology
Mm-hmm.
in masters. And then I chose a project which was closer to physics. And then in masters, I chose a project which was even closer to physics. And in my PhD, even closer to physics. And in my postdoctoral, I'm in mechanical engineering department now. So I think I'm curving out, and probably in my next job I'll be pure physicist. Who knows? So that's been my story. Yeah,
Right, right, right. That's something interesting.
yeah. So something you might have not expected.
Yeah, yeah. Uh, and Swarit, you said that you did your bachelor's in chemical technology, not even purely
Exactly.
in chemical engineering. So, like, this happened to many of the youngsters who is opting engineering. Like, they don't get the field they are expecting. And field-wise, now the most trending branch is computer science, because it has a high scope and it is in demand.
Yes.
Likewise, yeah. Likewise, do you think, like for chemical engineering or maybe chemical technology, what is the scope of field in India, and what are the companies that would be looking forward to hire these candidates? Also, does it come into government sector or private sector?
Okay, sure. Let me brief you. So chemical engineering nowadays, it's not that traditional chemical engineering anymore, to be honest.
Mm-hmm.
And this is somewhere where I think that the Indian universities are still falling short of coping up with that change.
Mm-hmm.
So if you look at all across the globe, and just try go to some university and look at their chemical engineering department, uh, there's a high chance, or I would say, I'm not sure about the data, but I'll say at least one third of the big universities, their chemical engineering department will be named something like chemical and biomolecular engineering department, or chemical and biotechnology department, or chemical and in some places chemical and materials department. So I am doing in collaboration a project in collaboration with the University of Alberta, for say. Their department is now named Chemical and Material Science Engineering. My department at Monash University, where I've done my PhD, is now named as Chemical and Biomolecular Engineering. And this change has happened while I was doing the PhD. So chemical has become more diverse. It's no longer the traditional where you are designing a boiler or a distillation column, or a pump and compressors and those kind of things. Although that is still there, but a lot of R&D jobs in chemical engineering is now coming from all the big silicon manufacturing companies and all. So
Mm-hmm.
I was attending one of the like one lecture from I don't know, from Stanford, I guess, and there's a very senior faculty, and he used to ask this question, and it's like 10 years back. I don't know what's the scenario now, but he used to ask this question that, okay, what do you think? What type of engineers are mostly recruited by Intel? So people are like, okay, electrical engineers, electronic engineers. They're like, no, chemical engineers.
Oh.
Why? Because there's a process of converting silicon
Mm.
into that kind of PN junction diode and then transistor and whatsoever. And that process is heavily controlled by chemical engineering, right? So since there's a part of Intel which is doing all the, okay, so when you design a chip, right, it's lithography is the
Yeah,
technique
yeah,
that
yeah.
they use to
Right,
design the
right.
chip. And lithography is purely chemical engineering, right? So in my master's, I've done a course which is called as instability and patterning of thin films. uh, and that course actually teaches you about all the different kind of lithography, where photolithography and other types of lithography as well. So chemical engineering has a lot of scope all across the globe. But when
Mm-hmm.
we talk about India, the problem with India is we don't do a lot of R&D, right? So if we are going to set up a big manufacturing plant, we are
Mm-hmm.
going to hire somebody, or we are going to give a tender to some foreign company, and then they'll bring their own R&D and their own staff and support in their own process. And what they want from India is like just manpower. Okay,
Mm-hmm.
so that's where we lack, in advanced chemical engineering, and that's why we are still offering traditional chemical engineering jobs to people, like by PSUs. All the big PSUs, you'll get a good chemical engineering job. But if you still want to do advanced chemical engineering or modern chemical engineering, there are companies like KLA and other companies who work in the domain of silicon industry and other domains, and they can hire you as well. So you can easily look for a job in pharma companies. You can easily look for a job in Dr. Reddy's and other kind of chemical companies. Even Lansex and other companies do a lot of chemical supply and manufacturing. And you can go for companies like KLA and all. So these are the companies who do offer a job in core chemical engineering sector. And obviously there are PSUs if you want to do the typical coal and oil and gas kind of engineering.
Mm-hmm.
In addition to that, I would also like to tell you that there's a huge scope that is going to come in the sector of renewable energies, as well as in the sector of like renewable and clean energies basically. And all of these energies will require lots of chemical engineering, no matter if it's wind energy, hydro, solar, whatever. It's going to require a lot of chemical engineering. On top of it, these kind of energy require you to store them, because sun doesn't shine all the time, wind doesn't flow all the time. So you need to store them somewhere. And there you get to know about battery technology. Battery technology is just lithium ion and all these sort of things. There you
Mm-hmm.
go, you have chemical engineering again. So yeah, there's a huge scope that is going to come in renewable energies. So whoever is going to do something in chemical engineering, I would suggest to look into these kind of present, I would say, niche areas in India, but they are more so, the trendy fields in all across the world. And you should look for, scope in these kind of fields as well.
Mm-hmm. Means generally speaking, chemical engineering has scope in every field, but mostly there is at this point there is less in India as compared to the Western countries, and that is also limited to some PSUs. And a major drawback is that due to we don't have much of research going on in India in this field.
Mhm.
Also, I noted that this one interesting point that you told that in Intel, chemical engineers are the most that is recruited.
And,
And
yeah,
yeah.
that used to be the case, at least. Like, so the lecture that I attended was like, a recorded lecture
Hmm.
that was delivered in 2007 or 8, I guess. But if you want me, I can cross check the fact and tell you that that's the case or not. But yeah, like Stanford, professor from Stanford in his class told this as a fact, and you can understand it as well, right?
Yeah, yeah.
How are you going to convert silicon into, like, it's going to be from some kind of lithography process, right?
Yes, yes.
And how are you going to follow Moore's law, right? If somebody is not giving you structures in the domain of nanometer or some sub-nanometer level,
Right.
right?
True, true.
So it has to be done by some kind of chemistry and chemical engineering. Yeah.
Right, right. I'm quoting this out because after 12th, my first choice was for chemical engineering. But
Oh, okay.
yeah, I want like in my case, my branch was I needed branch of chemical engineering, but I did got like the college for chemical engineering. Like there are very few colleges in my area. That is one point. And secondly, I wanted to like work for some companies like Intel and everything, like semiconductor industry. And
Okay.
I thought maybe like chemical engineer, what's the role over there? And that's
Yeah.
why I took electrical. But that's something interesting.
Ah,
Even if I had
yeah.
took chemical engineering, I may have ended up like going into the
Yeah.
same field.
Yep. Exactly. Yeah. And so and also I'll also tell you one particular thing.
Mm,
So you know okay, let me tell you. So every chemical engineering process, right? So you get some kind of a raw material and you want to somehow create value into that raw material, right? So there's a process in between that creates value into raw material.
mm,
I'll give you one example which everybody is trying to do nowadays, is somehow capture the CO2 from the atmosphere. So that is CO2 capture, right? So once the CO2 has been captured, somehow convert it into other chemicals which has more value. So let's say you have CO2, you bring hydrogen from somewhere, create methane, methanol,
mm,
ethanol, other chemicals, right? But converting, let's say you have a $1 cost of CO2 and you generate other chemical worth of $3. So there is a $2 profit. But during the conversion, you are spending $5,
mm,
right? Then it's the whole process is not profitable. So somehow chemical engineers wants, what they want to do is like make that process more economical.
mm,
And how do we do that? We try to innovate, we try to have materials, advanced catalyst, and the way the field progresses in last at least 20 years, we are now discovering more and more advanced catalyst to make that process work. So for this particular reason, if you look at companies like BASF, right? Companies like Exxon, right? Companies like uh, I would say Shell, right? These kind of companies are trying to recruit people who are having fundamental knowledge of science,
mm,
right? Physics and chemistry at the molecular level, and they are now trying to understand things at that scale so that they can make these processes more feasible. So yeah, like chemical engineers have a bright future, but the norms of traditional chemical engineering has been broken. So when you go to a university and a college, do study your boilers and distillation towers, separation processes, whatsoever. Do study all of them, but also keep an eye on the latest research that is going on in the field of renewable energies, in the field of advanced materials and all. That would be my advice. Yeah.
okay, nice. Also, Sarit, I see that your mostly career is focused more on research work. But before that, after your undergrad, did you like try to like did you had any off-campus or on-campus placement scenarios, or did you just appear for the gate directly after your grads?
Okay, so I have a funny story to tell here as well. So,
Mhm.
do we have time for another short story? How are we
Uh,
doing?
yeah, yeah, like you can just take your time and then we will just edit as fast
Sure.
like needed.
Okay. Okay, I'll keep it short. So it's okay. So let me tell you. So in my final year, right? So I obviously wanted to sit for a job, right? But my percentage was not good. Okay, so my
Mhm.
percentage was not good. I was a good student always, right? But the branch that I've taken, leather technologies, I had no interest. Okay. And the, like, the teachers also didn't make me interested in that field, or anything else. So anyways, I didn't do academically good because I didn't want to do. So that was by choice. But anyways, if you don't do good academically, you have less chances of getting placed, right? So TCS came. Okay, so
Mhm.
TCS is like a truck, right? So TCS came and they want to recruit everybody from every field, right?
Yes.
I gave this written test or something. Obviously I was selected in the written test, right? The next day they conducted the interview or something, and I couldn't go through the interview, and I'm not sure why. I still don't have an idea on why. We were waiting for like 4 hours for our turn to go and give the interview. And
Mhm.
by that time, my sleeves were folded for sure. And the first question that I got in the interview, that why are your sleeves folded? I was like, does it make a difference? I don't know. But anyways, that was like a point for them. But anyways, they didn't select me. Okay. And they were giving like a package of what, 3 lakhs or something. But
Mhm.
now I realize that that's for the best. By that time, I like, before the interview, I was like, "Oh, TCS is such a massive company. You know how many branches they have across the world, and so on and so forth." But anyways, I so then after that, when I was not selected, I just took it upon me, and I was like, "Okay, let me do what I enjoy the most." So I wanted to learn maths. I wanted to learn physics. I wanted to learn these kind of things, and I did it from the scratch. So there is MIT Open Courseware that is available, and I completed their Calculus 1, Calculus 2, which is multivariable calculus, and then differential equation course and other courses. I was just thoroughly enjoying, and I started preparing for GATE. Luckily, the second company that I applied for was Mu Sigma. So have you heard of this company called as Mu Sigma? It's a data science company,
Yes, yes, yes,
and
yes.
they give a pretty good package,
Yeah.
and they are like very well reputed. So they came and I applied there. So because my percentage was allowing me to apply to a certain company only, and that was the
Mhm.
second company I applied. And I think their package was at least 2.5 times more than TCS.
Yes, yes.
And there I got selected
Oh,
after 7 years.
nice.
So, and my mathematics helped me. And I was like, I was very frank with the people, and I couldn't care less during the interviews. My sleeves were still folded. I couldn't care less, and they offered me a job, and I got a job letter, and that was before my gate. But I still prepared for gate, and I still got a good rank in gate, and I didn't join music. I decided not to join Music and do my research. Like, just do what I like to do.
Right, right,
So
right.
yeah, so I got placement from college, and that was Mu Sigma. And I and but it's better to know that I didn't got get placed in TCS than to
That's
know that I
actually
got placed in Mu Sigma. So
that
that's why
can act in your favor actually because it's something
I could
main.
have just hided that, right?
Yeah.
So, right, but it's for other people who are listening. I think it's better to know that I didn't get selected in TCS, and I got a job in Sigma. So please, like, people who are taking your interview, just don't think that they always have the capability that they can judge you. Okay, so yeah,
True, true, true.
that's one story behind my placement. I did get placed in Mu Sigma data analytics company, and it's a very, very, very good company, I would say. 3 years they try to like take the juice out of you. That's my understanding, because these companies, they look for people from younger age. Because after a certain time, if somebody is 35, no matter, he has so many expertise, right? But now he's a married guy, right? He'll do your job 9 to 5. After that, he has a family to
Hmm.
take care. So but bachelors, straight out of college, they want to impress people. They want to be, you ask them to work 8 hours, they'll work 12 hours for you. So Mu Sigma will take the juice out of you for 3 years, but in 3 years they'll make you a very, very, very good um, analytical person. so you can get job, at some other bigger companies. That's my understanding of it.
Got it, got it. And in leather technology, is most of the branches don't actually have any subjects related to coding or something that is related to computer science. But how, like, were you, like, did you had in your undergraduate course, or did you actually prepare for this coding rounds or something like that? Because you told that like, Sigma is like the company for data science. So how were you able to like go into one of these companies?
All right. So I would say that for music, I prepared for one day. Okay, I had no computer science course. I know how to write C code from my, I guess, ninth or 10th class. I did
Okay.
some coding in that class at
Mm-hmm.
that time, and in the BTech first year there was like very small
Yeah,
course which
it is a
everybody goes.
common in
It's
BTech
a
first
common
year.
course,
Hmm.
yeah. I think by the time they go till pointers or something, everybody, gives up hope, and then they just give some exam and that's it. So it's
Hmm.
not a lot. And then also you don't remember it after a while,
Yeah,
right?
yeah,
So I didn't know coding, but I knew I had this much clarity that coding is, it's a lot of people think that knowing syntax is coding. Okay, that's not coding.
yeah.
So if you want to be a good coder or a good programmer, you need to understand how algorithms work, right? So I had a pretty good understanding about algorithms and how to, frame things. And what Mu Sigma did was, they asked to write pseudocodes. They asked to read pseudocodes, not like exact computer programs. So yeah, and I did do that, and they were very happy with my understanding of algorithms. So yeah, so that's how it works. And also, like, I'm some person who's like, who makes their ideals in different fields. So in computer science, my ideal is, I'm not sure if you know about them or not, but it's Linus Torvalds and Richard Stallman. So they both are the guys behind the open source movement and Linux. So Linus Torvalds is the person who made Linux, and Richard Stallman is the guy who started the GNU project. So I kind of, hear their interviews and their, public seminars and all, and I get a lot of information from there. So actually I can talk to a person who is in the same field, but I probably cannot do it myself, but I know it enough to understand what they are saying. So that helped a lot. Yeah.
Nice, nice. And next, you did your master's from IIT Kharagpur. So how was your experience over there?
Oh, KGP is amazing. It's amazing place. So the best thing about KGP is that, okay, so Kharagpur is a small town, right?
Hmm.
And there are only two things in Kharagpur. One is the railway station, and other is IIT, right? Everything
Okay.
else is like pretty non-existent there. So your whole life goes on in that whole campus.
Mm-hmm.
And I just love the campus. I just love the campus. I love everything about KGP. So yeah, so I enjoyed the studies there. I love the library there. I like the culture. I like doing my research project. My supervisors there. Um, uh, so although I was a master's student, after doing 2 semesters, you kind of do a research project for the last 2 semesters. And I used to have my lab keys, and there was a like a sofa there in the lab. So if
Mm-hmm.
you want to sleep, you can sleep inside the lab. You can take your pillow and rest in the lab itself and do your research. So I just thoroughly enjoyed KGP. Uh, what I didn't do in KGP is I did not sit for placements, and that
Mm-hmm.
was my choice. So a lot of people sat in placement, but I never sat in placements in KGP. So that was something that was my choice this time, because I wanted to do research.
Got it, got it. And like chemical engineering. We know very few things like for most of the undergrads over here. Like when it comes to computer science, we can say, okay, operating system, this is one of the subjects, data structure and algorithm, DBMS. For electrical, it's electrical machine, maybe something like that. So can you just name few of the courses that you took? Because at master's level, you are now doing in chemical engineering particularly. And so can you just name some of the courses that is major relevant to become a chemical engineer?
Okay, so I'll segregate the subjects in two different parts. Okay, so one is subjects related to traditional chemical engineering, then other subjects that are related to those advanced and new, more modern chemical engineering, which is more interdisciplinary with physics and material science and other subjects. Traditional chemical engineering, you study transport phenomena, right? So transport phenomena, or I would say you study, how three things gets transported. One is material, so that is mass transport. One is momentum, so that is momentum transport. And the third thing is energy, so that is heat transport. So like, if you have a, let's say if you have one fluid stream which is hot, right, but it's just going to waste, right? So there's a fluid coming out of the reactor which is hot, right, because
Mm-hmm.
reactor is working at high temperatures, but this is just a waste stream, right? But you would want to recover the heat from it,
Mm-hmm.
right, because heat is energy. And so what you do is you try to send this stream to a heat exchanger where you have another fluid which is somehow in contact with this physically, or by a separating wall, and you try to transfer heat from this waste stream to water or some other thing.
Mm-hmm.
There you want to optimize this heat transfer, and you don't want to waste too much energy in this. So that is called as heat transport, right? So like this, there are other transport phenomena as well. And then you have reaction engineering. So this basically, they talk about the rate of reaction and all these different types of things, and rate of reaction in combination with the size of the vessel, size of the reactor, and all sorts of different things. So that is basically traditional chemical engineering. And on top of this, there's one more aspect of traditional chemical engineering is design of controllers. So that has a lot of instrumentation and process control algorithms. And even we study algorithms like DMC controller and all the other types of typical algorithms of control and process engineering. We study that. So that is another aspect of traditional chemical engineering. Now coming to more sort of advanced chemical engineering, you get courses like advanced materials. There are so many fascinating materials like graphene, like metal organic frameworks, like so so many peroxides, and so many advanced materials are there. So you study them. So that's called as advanced material science. You study let's say you study lithography, instability, and surface patterning. So that is also taught in chemical engineering. You study computational chemistry, which is my field right now. So basically, you try to solve atoms and molecules. You try to study them using Schrodinger equation. So
Mm-hmm.
that's like as hardcore physics as you can get. And yeah, so that's called as computational chemistry. And like these, there are some other advanced field as well, like you study enzymes and enzymes and bacteria and these kind of things as well. That's not my domain, but yeah, that is also taught in chemical engineering.
Okay, I asked this question in particularly because I remember in my back times, like in 12, when someone said chemical engineers, most of us thought like maybe we had to again like recover all that
Hydration.
periodic table and maybe benzene rings. We had to draw all that organic structures, but that's
Uh,
not true. Like it is a diverse field and it is more like an engineering rather than just
Look, I will tell you this thing that a lot of people, right? And I've interacted with a lot of people, and they don't have a very good understanding of um, let's say they don't have a very good understanding of organic chemistry, and they still do pretty good in chemical engineering because that's not their domain, right? If they want to know some expertise in, they want to know about it, they collaborate with a chemist, right? Chemistry people also need a job, right? They cannot just like chemical engineers comes and now all the BScs and MScs are like worthless. So they take help from there. But yeah, if you want to be
Okay, Swarit, so you decided to move your career more oriented toward research, and thus you thought to go for PhD. Why did you choose Australia in particular, and which exam did you appear for this?
okay, so again, Australia was not my choice, and I didn't know anything about Australia.
Mhm.
And I would like to name one of my very close friend, Vivek. So he was doing integrated masters in chemical engineering, and we worked on the same project in KGP. So the story behind this is that I didn't have a good percentage in bachelor's, right? So it still counts. I don't know till what level it counts, but it does count. I have a very good percentage in KGP. So my pointer in KGP is, I guess, 9.1 out of 10 or something.
Mhm.
So KGP was good, but still bachelor's, there is a, baggage. And I didn't know how much it affects. So I wanted to go for a GRE, but somehow I wanted to take a year break because I was having a couple of publications from my master's, which was going to be accepted any day. And if I could have gotten those publications and if I would have appeared for GRE, I was getting a chance of, going at one of the very good universities in US, at least.
Mhm.
That was by design. So that was my plan. But Vivek told me that why don't you apply for Australia? I was like, I don't know about Australia, right? I just know their cricket team, right? I don't know about universities in Australia. But he's like, no, seriously, try it. And that time he was in the Netherlands doing something. But anyways, so he did ask me to apply there. And I did apply, and I got this project where it's on catalysis, but I'll have to do computational chemistry, which
Mhm.
is working with molecules and either Schrodinger equations on Newtonian mechanics or statistical physics, statistical thermodynamics, and I was just in awe of that. This is I was looking for for so long to go closer to physics. My master's project was computational fluid dynamics, and now I was like one scale down and going on the surface of molecules. So my potential supervisor at that time, he was very happy with the interview, and he wanted to offer me a scholarship. And I was like, okay, why not? So I chose Monash University in Australia, and Monash University is pretty reputed in chemical engineering. It's one of the top 30 universities in the world in chemical engineering, consistently for last at least 10 years. I think so. So yeah, so that's how I chose Monash. And I would not want it any other way. I love Monash. I've collaborated with so many people in my last 4 years there. I've been to nuclear reactors. I've been to X-ray synchrotrons. I've been to conferences. I've been to Nanyang Technological University, Singapore,
Yeah.
because of Monash.
Mhm.
I've been to Pennsylvania State University for 2 months scholar visiting research due to Monash. I was scheduled to go to Lawrence Berkeley National Physical University, that is next to UC Berkeley, but it's a national laboratory of US government, one of the best in the world. I was scheduled to go there in 2021, but then COVID happened. So I put a proposal there. It's very hard to get a proposal accepted there,
Mhm.
and I got funding from Australian government to go there. So it's not that my university was funding me. I got another funding from Australian government to visit that lab. But unfortunately, due to COVID, I couldn't go. So Monash gave me lots of resources, and my supervisors have been like really, really, really kind people. So I would not want it any other way.
Okay.
So yeah, so people who are aiming from Australia, right now borders are closed, so you are unfortunate.
Sure.
But if they are open and you want to go to Monash or other good universities, Australia is very, very, very good for doing your research and even a career afterwards. It's a pretty good place.
True.
Yeah.
But one of a drawback that master students or someone who is going for, yeah, mostly masters is that
Mhm.
Australia is expensive. And but I see that you did receive scholarship. Also, apart from scholarship, like for PhD students, is there any stipend that is given
Yeah.
or what?
So yeah. So I don't know how people figure this thing out, but if you can figure it out, it's good to go for masters in a foreign universities. Very good. And I've not seen regrets from any person so far that I've met, that I spent this much money and I went to a foreign universities for masters. Now I'm regretting it that I spent money.
Mhm.
I don't think so. If you are sincere enough, you'll figure out a way, and you'll whatever education loan or something you have taken, you'll clear it in certain time duration. uh,
Mhm.
for me, look, I was working for the pure point of view of for the love of science. So that was my point of view. So I couldn't take this mental tension of a loan, this or that or whatever. I was just like, okay, there's a path. Go to IIT. From IIT, people go outside. It's very much heard of, very common. So yeah, I took that traditional path. Now, so I cannot comment on that. Living wise, it may be expensive, slightly expensive, depends upon how you would want to live. But Indian people do have a tendency of figuring out the cheapest way possible of living anywhere in the world. So it's not that costly as well if you are an Indian fellow
Mhm.
uh, and uh, and want to live in a cost effective way. For PhDs, I was paying no tuition fee whatsoever. There was a tuition fee, but it's coming from one of my scholarships.
Mhm.
So it's around $40,000 a year or something like that, which one of my scholarship was paying. And in addition, I was getting around $2,200 a month as a monthly stipend. And in addition to that, you sometimes you teach for the university.
Mhm.
So you become a teaching assistant or something.
Yeah.
So in those cases, you earn, I don't know, somewhere around $4,000 per semester. So in a year, you earn additional $8,000 just for your TA duties. So yeah, it's a pretty good deal. So over and all, so you get somewhere around, I guess, if I include the teaching duties, you get somewhere around 2,900 dollars Australian dollars a month, which is pretty okay. Like if you are living like pretty good. Like I'm not even saying like cheaping out at a lot of things. You are having a pretty nice place to live. You are spending all equivalent to other people from other countries as well. Then also your expenditure won't be more than $1,500, let's say 15, $1,600. So yeah, like you can save $1,000 per month if you are a PhD student. So yeah, so if you want to do PhD, it's pretty good,
I
buddy.
think
Like
that is a good trade-off, like because you would be working on something that you're interested in, and apart from that, you get paid for that. That's
exactly.
nice.
So a lot of people, $1,000 if you are saving, so that's equivalent to 50,000 rupees in Indian currency,
Mm-hmm.
approximately. So this is a lot of people's earning, not saving, right? So if you are able to save this much, so it's a, like if a person is earning 1 lakh rupees after taxes, so PhD thing is without tax, so you don't pay any tax
Mm-hmm.
on PhD scholarship. So if somebody is earning 1 lakh rupees after tax, then they might be saving 50,000, I guess. So it's like equivalent of that. So and then you are doing PhD as well. And after PhD, you get a job, buddy. Like if you want to do a job in foreign, you'll get a job very easily. If even if you want to go to industry, this is a sort of a skewed and screwed up culture in India, that bachelors are ranked here, then masters are below bachelors, and PhDs are like even below masters for some reason. I don't know why, but yeah, that's the culture somehow. So I don't know. And
Actually,
I get this question
mm,
very often at so many places, that like, how much do you want to, like, how long will you study? So I'm like, I'm studying and I'm earning as well, so it's fine. Yeah. So to
uh,
answer your question, you can live happily as a PhD. Masters, I haven't figured out that game, but I see a lot of people that take, educational loans and stuff, and they somehow figure it all out in the end. So yeah, so that's the thing. And also, if you do a PhD or a master's there in Australia, for masters you get, I guess, a visa for 2 or 3 years. I think for 3 years, I guess. And PhD you get an additional visa for 4 years to do job in Australia. So you get a
mm.
work visa for 4 years. So yeah,
Can
so
someone
that,
like appear for PhD directly after like bachelor's?
yeah, you can
Okay, so we don't
certainly.
have to like compulsory do masters and
No,
then
you
go.
don't have to compulsory do masters, but there you'll have to somehow prove that you are exceptional student, because the underlying assumption behind that is, look, this person is such a, like, so exceptional, that this person is so focused in his life and his goal, that that he or she wants uh, can do a PhD even without doing a master, because master is sort of a training, in between PhD. I don't think master is necessary for PhD, but it's like a training for PhD. So yeah, so if you have done good in academics, so you have good marks, or you have done a job somewhere which is relevant, or let's say you have published a paper, or let's say you have attended a conference, or something, somewhere you have to prove that you are capable of that. So yeah, you can still get a scholarship.
Got it. And I missed one point. Like you did your thesis from IIT Kharagpur, and which
Kharagpur,
uh,
Kharagpur,
sorry
yeah,
Kharagpur, and
KGP.
yeah, which thesis was it? And apart from that, can you just point out one of your research that you would like to elaborate to the audience?
Okay, so I'll answer this with the correction. So obviously, yes, I did my thesis from KGP, but that was my master's thesis. My main thesis is my PhD thesis. So would you like to know about PhD thesis or master's thesis?
Anything that finds
Anything
more
that I would
interesting.
like. Yeah, I guess that. So so okay. So I'll tell briefly about master's thesis, PhD thesis, and what I'm doing right now. So my master's thesis was focused on creating nanostructures by using electrohydrodynamic patterning. So basically, you have an electrode, and the gap between two electrodes is about 100 nanometer,
Mm,
and you coat a polymeric film in the bottom electrode, and you
mm,
apply electric field and try to make patterns, pillars of polymers, which are, at a certain gap. Why do we want to make those patterns? Because they have too much uses. In your mobile phone, you have like the screen, and the screen has different features. It's holophobic, or some other features are there, so they are created by those patterns. um, uh, and then in your okay, there's a fun fact. So these screens, they have a glass on top of it called as Gorilla Glass,
yeah, yeah.
right? So during my visit at Penn State, and I've co-authored the paper
Mm.
with one of the professors in Penn State, and he is the co-inventor of Gorilla Glass.
Oh,
So Yeah, so it was like and it's pretty high material science. So he was a scientist. He was a principal scientist in Corning, one of them, the company who owns Gorilla Glasses. So yeah, so that's it. But anyways, so that's electrohydrodynamic patterning was my master's work. My PhD work was related to efficient conversion of CO2 into value-added chemicals. And I basically studied formaldehyde methanol water systems. I studied ruthenium catalyst and other systems using computational methods. So what I used to do is I used to get a system and I design it on my computer and I predict the outcomes, and I also tell them how these things are working and how you can improve your method as well by understanding things at molecular level using my computer and other supercomputers around the world. And my postdoctoral work, I'm doing multiple projects in postdoctoral work, but one of the main project is designing a material, shielding material for a fusion reactor. So
Mm-hmm.
fusion reactor is basically, building a sun in a lab. So small sun in a lab. So sun, the plasma. So sun is like fusion reaction,
It's
right? So
like
hydrogen.
Doctor Octopus if you have seen Spider-Man
Yeah,
2.
yeah, yeah, something similar. Yeah. So recently, if you look at the news, China has actually built a successful fusion reactor at a massive scale in 2 3 months back. But the fun part is that, let's say if you take a bucket of water, bucket of D2O, let's say, you can probably, bucket of D2O, right? Which is not like too much. But with that, you can probably provide energy to the whole world for like 10 years, let's say.
Mhm.
Approximately, it's that scale we are talking about. And it's not very hard, right? D2O is like very common. You will get like bottles of it in lab. And another best part is, if the reactor, let's say, breaks, it doesn't contaminate, it doesn't release radioactive rays and all like other fission reactors. Fusion is like pretty cool. So fusion is basically hydrogen particles joining together creating helium and other, and in that process they lose some mass, which is converted into energy, equals to mc square. And but in sun, what happens, that sun has so much mass that its own gravity is keeping everything combined together. So, everything is colliding and doing the reaction, but it's not falling apart. Sun's own gravity is keeping everything in a circle. But in our world, even if we somehow manage to collide them together, we somehow need to capture them and keep them in a confined space.
Mhm.
So so this reaction space is a plasma, and plasma is charged particles. So people are having magnets around, and with the force of magnet, they are keeping things in a confined space.
Mhm.
But still there are some particles that occasionally come off and knocks off things and so on and so forth. So anyways, my job is to design a material that actually confines this sun,
Mhm.
artificial sun, where the temperature is around 10 million degrees centigrade. So in a smaller space, and there is some material engineering that we need to do, and then as this aspect. So yeah, that's one of the things that I'll be doing in the next coming couple of years. I hope so. Yeah. So yeah. So look, chemical engineering, right? So
Yeah,
it's not traditionally like boilers and distillation towers only. It can go to places.
yeah. And are you currently working on this, or like this is your previous project that you had?
So
Also,
this, yeah.
you told like
Sorry.
you are not working like something in a lab or like a traditional chemical engineer. You are working more on computational things.
Yeah.
So just elaborate on that.
All right. Yeah. So even this project, that this whole reactor thing, right? Like these, there are like 7 8 reactors people are building all around the world, right? And their time scale of building them is goes in like 30 years or something. So the some of the reactors will be operational in 2060, let's say, right? And right now I'm one of the teams that is funded by the US government. I'm part of one of the teams that is funded by US government, that is like trying to design a shielding material. How do we design it? We first design it using computers,
Mhm.
and my job is to design it using computers. So computers, I'll create molecules, I'll assign their interactions, and then I try to hit particles with high energy to that material like a game, right? And I'll see the behavior of the material once it happens. It can be a very fictitious game if you don't know the chemistry behind your assignments. But if you know the chemistry and you can design these things, they even if you do experiments in future, you'll get the same results basically. And that's what has been our experience so far. So I'm a chemist, uh, I'm a chemical engineer, but I don't work in labs. I don't
Okay.
work in labs. So I either take my samples to big spectroscopic devices like X-ray synchrotron or neutron reactors to understand what is inside my sample. Sometimes I do go to lab to prepare that sample, or sometimes I ask people to prepare such samples for me, and I test them in those spectroscopic methods to understand what is the molecular composition by experiments. And mostly what I work on is on my laptop. My laptop, I can connect to some of the finest supercomputers in the world. So I still have access to Australia's national supercomputing infrastructure. I have access to Monash's own small supercomputer. I have access to Compute Canada, which is Canada's supercomputer, and one of Penn State supercomputer. So you can, in these computing infrastructure, you can, even if you want at a time, you can use, 500 cores. You can use 2000 GB RAM, right? So even though I have a desktop which has 128 GB RAM, but I cannot match like 500 GB RAM, right? And 2000 cores. I cannot have 2000 cores with me in my home. So, but you can do such simulations in those supercomputing infrastructure. So my lab is my laptop and my desktop. I don't go to labs. So during the COVID times, the 2 years of COVID, I just worked from home,
Okay.
and I was fine. I didn't need to go to any lab.
Uh, that's incredible. The way you actually describe the like how your daily life look like. This is something that actually all of us wanted when we imagined to be a scientist or something. But yeah,
Yeah,
mm, this is
and
something that is in your favor. Actually, it's a great thing that you accidentally chose chemical engineering and then
yeah,
uh, it turned out to be in your favor.
yeah.
Um,
Imagine where would I have been if I would have continued with TCS. Right. So I'm not taking a dig at people who continued with TCS. I know a lot of great people, not taking a job and not taking a dig at them. But look, people rejected me, so I have my fair share to hit them back. That's a scenario. And also, I would like to stress this one point. Look, coding, although I've never learned it officially, any of the courses, right? But I by myself, I have learned, I know JavaScripts, I know Python very well. I know HTML and CSS to like a certain level. And there's a Google's own coding, which is based on JavaScript, that is called as AppScript. I'm very good at that. And so, you need to know coding a little bit. But the people who think that, oh, coding is everything, you are fooling yourself. Because if anybody can write code, man, it's not that difficult,
yeah,
right? But the difficult part is to understand how atoms work, right? So if any computer scientist, even they know like lots of code, right? They cannot come and interfere with my job, right? although they can get tons of jobs that are related to, Amazon and, data sciences and understanding the mood of customer and whatnot, that's fine. But if somebody is going to send a rocket on Mars, right, the calculation will be always done by a physicist. So yeah, so that's something which people also need to take into consideration, and don't be always fooled by coding. Coding is essential. Coding is very good. We all should learn coding, and I think coding will be in 3 or 4 years. And I'm not sure if it has already become, but it will be just like mathematics, right? So if you
Yeah,
you know mathematics, do you know coding? So it would be something similar to that. It would be more like an aptitude than like a speciality per se.
that's
Yeah,
right.
my point
Uh,
of view.
Great. Thank you, Swarit. We would be heading towards the end of this podcast, and it was great talking to you from this episode. I actually learned more about what it is after choosing a chemical engineering, and I am sure that many of other of our audience would be getting more of insights of what could be a career opportunity after choosing this career path.
Yeah.
Uh, and of course, I'm sure that you would be also interested. You would be also enjoyed this podcast.
Oh,
So
thoroughly.
before ending this, is there any final advice that you want to give?
No, it's just like, look, everybody's career path and everything is your own, right? Nobody has ever done what you are doing and what you are about to do. So you are unique, right? So follow your career path. Even the small setbacks might be in future might be the best thing that will ever happen for you. And yeah, I would like to say, if people would want to ask for some advice or some comments or anything they want to discuss, you can find me at a couple of places in social media or whatever way. Approach me and I'll be happy to answer, talk to you if needed. Yeah.
Got it. Thank you.
Right. Thank you so much, Sandeep. Thank you.